We continue the introduction to time series data, and this is part 2, focusing on cleaning and observing the main features of a time series. In this lesson, you will be introduced to some time series data quality problems that require action before you even consider describing the data. You will learn to visualize some features of time series after the data has been cleaned, such as trend, seasonality, irregular components. Why do we need to know that? Well, dirty time series data is useless data. Garbage in, garbage out. We may be fascinated by the things we see, but they could just represent mistakes in the data, not real facts. Once a time series is cleaned, the main next step is to appreciate its most general features. The first features we look at are the trend and the seasonality. Knowing the general features, we can use them to forecast the future. Like all data, time series data must be inspected and cleaned. We should ask, is there a timestamp? Without a timestamp, we have a big problem. We will not be able to tell whether the data are time series or cross-section data. Then we should ask, is the timestamp in order? 8 a.m. of Monday is before 9 a.m. of the same Monday? Okay, if that's the case, then we are okay. January of 2019 is before March of 2019. If that's the case, we are okay. Make sure the data does not contradict that. Now, based on the timestamp, we should ask, are the observations recorded monthly, annually, daily, hourly, weekly? That is very important and will determine the type of analysis we will do. Are the data recorded at equally spaced intervals? For example, if the data, the time series is weekly, is the interval between two observations always a week? Do we have one observation for every single week? Are there breaks in the timestamp? For example, stock prices are recorded only during the 5 trading days of the week. The time series cannot be defined as daily, for example, because we don't have an observation for every day. Are there missing values? That is, an observation should be recorded, but it was not. Are there extraneous numerical codes that are not really data, but code representing something else? For example, the tag -200 could be used to represent a missing observation. Are the measurements intertwined with summaries of the data or some other data processing that is not really an observation? Are the numbers formatted with commas in them? Some software, such as R, does not like that. Let's look at an example. In this example, there are lines of data that are intertwined with summaries of the data. Here is an example. Here we have domestic and international monthly observations. These are passengers. Here we should take out the yellow row. The yellow row is not a monthly measurement. It's the total, the annual total for that particular year. It breaks the time series. The line with the total domestic and total international passengers must be removed. This one must be removed as well. Another problem is that if we use R, the commas will have to be removed. If you notice, the numbers have commas in between them. That is going to upset R. The solution would be to not work with this table. Do not just copy this table the way it is. Or if what you want to do is to look at the raw data that produce this table. This is just a table for publication, not to use for analysis. The raw data could be an Excel or a CSV file, and still you should check it because you may have the commas and you may have to remove the commas. Another example is when we have codes that do not make sense and they are embedded in the data and the software thinks they are data. Here is an example. Here we have hourly average responses from an array of NOx metal oxide chemical sensor embedded in air quality chemical multi-sensor device. So this is sensor data. It's the structure in such a way that they put a negative 200 every time there is a missing observation, the sensor fails. Then they put negative 200. In the plot, that is showing as a drop in the value every so often. The number negative 200 represents the observation is missing, not that the NOx is negative 200. The periodic drops to negative 200 in the plot are fictitious. They're not data. Ignoring that piece of information leads to erroneous conclusions about this data. R, for example, uses NA to represent a missing observation. R doesn't know that negative 200 is representing a missing observation. R will think that negative 200 is data, and as such, use it in the analysis, like in this plot. That gives the plot the appearance of a periodic drop in the value of NOx. Looks interesting and intriguing, but fictitious. You must stop that. Once the time series is clean, you should look for features that stand out. Of course, there are many more cases of dirty data that you will see throughout your learning. After it's clean, we should use time plots of the time series or windows of the time series. That means subsets of the time series. And then based on those plots, determine whether there are trends, seasonality, types of seasonality, holidays, unusual observations. You should investigate more closely each of the features observed by narrowing the windows of the observations. Don't use scatter plots to look for features. This is a scatter plot. That is the wrong plot for a time series. The data should be plotted against time with the points joined by lines. It should be a time plot. A scatter plot doesn't show us anything when we are studying a time series over time. The sequential nature of the data is lost in a scatter plot. Use time plots of the whole series first. A time plot has time in the horizontal axis, the measurement in the vertical axis, and the observations are connected by lines. This is monthly time series, as we can see, because we have 2012 January represented here, 2017 December. A time plot is a line plot of time series data against time, connected by lines. The observations are connected through lines in order to appreciate the patterns. Once you do your time plot, you describe the main features first with the right time plot. The time plot on the right is the correct plot. The sawtooth pattern that we could not see in the regular scatter plot now jumps out at us as the points get connected up. The major things we see now are an overall trend upwards and the sawtooth pattern. So thus there is a trend upward and a basic pattern that repeats every year. We call such patterns seasonal. So we might want to investigate those further. You can add a little bit more. You can use the metadata, the information about the data that you obtain in the source of the data, and your historical knowledge to help your description. We will not look for holidays because this is monthly data. It's an observation each month. So we will not see the holidays. There were no epidemics or catastrophic surprises during this period, so we are not looking for them in the data. And the time window is too short to observe business cycles. These are these periodic increases and decreases in economic and sociological variables that occur over time, and they are usually 4 to 5 years cycles. So we do not look for them here because the period is too short. If our curiosity leads us to investigate further the seasonality, then we can use the spaghetti plots. Split the time series that we were looking at into different segments and plot the segments superimposed on each other. So here we split the series by year. So we observe each year. And now we look at more detail. We look at the months in each year and then compare the years. This is a spaghetti plot, a plot of pieces of the time series. Each piece is a time series for a year with the objective of inspecting further the seasonality. What we notice in this lesson is that the time series could be pretty defective and useless for analysis with our software. We must check carefully the quality of the data. We should look for commas, missing data, existence of timestamp, the metadata to help us, strange codes, discontinuities, unequal time intervals between observations and other things. Once we free time series of all problems, it could have still unusual or extreme once in a lifetime features worth taking into account, such as holidays, epidemics, terrorist attacks, shock. When the time series is finally cleaned and scrutinized, we can then observe time plots to determine general patterns, trend, seasonality, holidays, business cycles. The intensity of our looking for details should depend on the frequency of observations and the length of the time series. I hope you enjoyed this presentation. There will be more in future presentations. Thank you for listening.